will try to be brief in order to try to recover a bit of the schedule time. Roland did a very good introduction or gave a good overview of this entire development. So ranging from what we started in 2010 and that we now have qualified devices quite recently, I think it's interesting to note that we still have something that we can describe as highest performance within the space industry. We may not be highest performance in the absolute number of computational number of computations you can do per time, but if you compare performance per power consumption or performance per euro and so on, the GR740 is still very much competitive. So even though it took us quite some time to get this into a product that could be designed into avionics, it seems that we managed to do something right. So a lot of this on this slide was already covered by Roland. I will spend just a few minutes talking about the architecture because it is the GR740 user day. We may have at least people online that are watching this to get acquainted with the product. So the GR740 is a quad-core architecture. It implements the Spark V80 32-bit architecture, where we have 4 processors connected to an on-chip 2 megabyte level 2 cache. Each processor has a dedicated floating point unit, and we run the entire system at 250 megahertz, and that's the worst case operating frequency that you can achieve over the full military temperature range. The external memory interface is legacy SDRAM, and the number of communication interfaces compared to earlier generations of space-grade devices have been significantly increased in terms of what we can put on one piece of silicon. Roland showed some earlier generation microprocessors. There are additional ones from Gaisler, for example, the GR740 RC, that has some of the GR740 features, but not all of them. Overall, what we do with the newer generations of microprocessors is that we improve we increase the level of integration one can do. So for example, there are users that make use of our GR712 RC dual-core Leon processors, and then they have a SpaceWire router next to that. With the GR740, we integrated the SpaceWire router on the same chip, allowing to immediately cut the number of required components into half. You will also see other presentations today, for example, from TAS Italy, where the GR740 drastically allows to reduce the component count in a system. Focusing on the news since the last user day, the big achievement for us was the qualification to QMLV. So we are very proud of this. It comes after a major amount of work, both at Gaisler with support from the agency and also at ST Microelectronics. It took significant effort and time to get to this level, and we are very proud of having achieved that. Roland mentioned the GR740 plastic development, and that is a development that was done within the ESA ARTES program. The project has now been completed, and we are doing an ESCC Q6013C Class 2 evaluation that's ongoing, so we are building the flight models. I think our schedule was to have them available in Q4 this year. That may turn into January. But overall, what we have available today is the high quality parts of the GR740 in ceramic packaging as a ceramic land grid array. You can also get it as a ceramic package with columns, and also this plastic PBGA version, both as prototypes, and we are accepting orders for flight models. I have a few slides on boards as well that I intend to skip now in order to save some time, since we got delayed in starting this. But I want to show you a teaser of something that Sandy will return to at the end of today. And that is an evaluation board that we're now designing. It's the GR740 mini board. The size compared to a credit card, you can see down in the slide here. And it's something that we intend to provide on loan to users for getting a rapid start developing with the GR740. And we are also combining this with Lattice Certus Pro FPGA. So expected availability of this one is in the first half of next year. So to try to sum this up, the GR740 development status, we have completed the activities from specification to QMLV approval. There is a final presentation on the qualification effort available online. There are also final presentations from the previous phases of the development. And I think it's nice to have those available and to be able to look back on them because they also contained lessons learned. Doing this within an ESA context and being encouraged to also share what didn't go right, I think that's a very nice thing, because there are a lot of expensive lessons learned that I hope we as an industry can avoid by sharing the information. We have the GR740 plastic package available. We have 2 capable development boards also directly available from us. And Beyond Gravity will today present also the development of a GR740 reference design for SBCs. Development doesn't stop here. We are at Gaisler increasing allocation of both product marketing and engineering staff to support this product and to expand collateral when it comes to examples, application notes, and so on. We have the new evaluation board in progress, the development of it, and we're doing continuous extensions and improvements of the software ecosystem. We're going to cover that in later presentations today. And when we see the GR740 being designed in and we're interacting with customers that are applying it in their projects, we are also continuously learning how to make better systems with the GR740, and we intend to keep sharing that information through example designs and application notes and so forth. So thank you very much for listening to this brief update, and I'm handing this over to the moderator again.